of systems by elimination. Okay, welcome to this episode on solving systems by elimination. So if you saw solving systems by graphing and you saw solving systems by substitution, this is similar. It's the third method of solving systems of equations. Some of these examples will be the same examples from those two videos, but with this method, and then some of them will be brand new. Okay, so let's go. Solving systems by elimination. I'm going crazy because I've been recording just a bunch of stuff over and over again. Anyway, so how to solve a system of equations by elimination. Choose a variable. Multiply the equations. Sometimes it's just one equation. Sometimes it's both equations. Number 3, get opposites. Opposites are -2 and +2. Opposites are not -1 and +3. They have to be the same number, one negative, one positive. Anyway, number 4, add, down, and solve. And then number 5, plug in that one answer and find the second answer, because you need an X and a Y and an X, because your answer has to be an ordered pair. Okay, best if equations are in standard form. Standard form is AX plus BY equals C. Let go. All right, example number 1. I have the answer already. I always give my kids the answers because I'm concerned with your process. Do you understand the process? Because PhotoMath can find an answer. Anyway, I'm going to get off my soapbox this time around. First thing that you do is you need to pick a variable. Am I going to use the X's or am I going to use the Y's? In this example number 1 out of 6, I'm going to choose the Y's because the coefficients of the Y's are already opposites. One is a positive, one is a negative. They did the work for me. Won't he do it? So we're going to go with Y's in this case, okay? If I'm adding the equations down, so top plus bottom, okay, what's going to happen is the Y's are going to go ahead and simplify out, right? They drop out because one is positive, one is negative. Get out of here, all right? So I'm going to add down. So that means I'm going to add purple X plus pink X, and that's going to give me 2X, and I'm going to add 8 minus 4, and that's going to give me +4. So now in this new equation that I have with no Y variable in it, I'm just going to go ahead and I'm going to divide by 2. X equals 2. I have half my answer. Does it match our graph? It sure does. So then I'm going to draw this little line here. Take the equation, and I'm going to plug in the 2. So the purple equation, it doesn't matter which equation I use. I can use the purple one or the pink one. I use the purple one, and instead of X, I put a 2 in there. I got to get Y by itself because that's the second part of my answer. I'll divide by 2. Y equals 3. Ta-da! Does that match what we had already got? Yes, it did. Okay, anyway, I'm being extra. Example number 2. We need to choose a variable. Am I going to use the X's and am I going to use the Y's? So in this case, it's just as easy to use the X's as it is to use the Y's because they don't match. In that last equation, the variables, the coefficients matched and they were already opposites. But in this equation, I got a 2 and a 1. And then I have a 1 and a 4. What am I supposed to do with that? So just choose any one. So we're going to go with X, right? What number, so this is the tricky part of elimination, what number would I have to multiply the pink equation by to make it the opposite of +2? Because I can get that X to be any number I want to. I just got to choose the right number to multiply it by. So obviously there's a 1 in front of the X, right? If I multiply that 1 by a -2, then I will have opposites. I will have a +2 in the purple, and the pink equation will turn into a -2. But remember, when you're multiplying equations, if you do it, you got to keep the whole thing balanced. So I have to multiply the X by -2, the 4Y by -2, and that 12 by -2. Okay? So we're going to rewrite our system. The purple equation stayed the same, so it's just right there. And the pink equation is going to be -2X minus 8Y equals -24. Yo, Miss B, you just did a lot. Like, what happened? Okay, so my students, listen to me. The tricky part about elimination is just getting the variables to match. I just need to get them opposites. So I had a +2. In that bottom equation, the coefficient of the X was 1. I can multiply 1 by any number in the world, to get a matching number. So the matching number I needed to get was a -2. So I multiplied everything in that bottom equation by a -2. So now that I have opposites, I could do it just like I did the last problem, right? Because what's going to happen is those opposites, bye, and I'm going to add down. -7y equals -28. I'm going to divide by -7, y equals 4. Does that match? Yes, the y is 4. So swoop. I'm going to plug it in to the purple equation. But Miss Bernard, you use the purple equation on the other side. Doesn't matter. When you already have half your answer, you have the x or the y, you can choose purple or pink. So here we go, baby. Divide by 2, x equals -4. Does that match? Yes, the x does equal -4. The y does equal +4. That matches my graph. I eliminated. Look at you. -4, 4 is my answer. Okay, example number 3 out of 6. I know the answer already. Oh my gosh, it's -1, -2. But do you know how to get it? By elimination? Okay, oh, too quick. I'm gonna leave that there, but I'm gonna explain my thought process here for a second, right? So we need to choose a variable, the x's or the y's. Well, I'm looking at the x's. I have a 2 and a -4. I could multiply everything in the top equation by +2, and then it would change the coefficient on the x to +4, which would be the opposite of -4. That is a good option. Or I could look at my y's, and I have a +y and a -y. I could multiply the bottom, which is what we're about to do, spoiler alert, by -1, because then my top y would be a +1, and my bottom y would be a -1. And those would still be opposites. So let's rewrite our system. The purple equation stayed the same. The pink equation I changed, okay? So now I have a +y and a -y. Are those opposites? They sure are. We love to see it, okay? So we're going to go ahead and get those out of here. I'm going to add down. 2 plus 4 is 6. Equals -4 plus -2 is -6. We're going to divide. X equals -1. Does that match what we had on the graph? Sure does. Look at me on the right path, hair flip. Okay, and then what we're gonna do is we're gonna plug it into the purple equation. So x equals -1. So instead of x, I'm gonna plug in a -1. So you can see that in the orange there. 2 times -1 is -2. I gotta get y by itself, so I'm gonna add 2 to both sides. Y equals -2. Does that match our graph? Sure does. Look at me doing the dang thing. Okay, so then we're going to do example number 4. I'm not going to give you a graph this time. No answer for you. Let's just see if we can get this, because this equation is actually not the same from the last 2 videos that I did, so that's why there's no graph. But I'm going to show you the graph, and I'm going to show you we're going to use the calculator just to check our answer. So because you always want to check your answer if you can. Know that you're on the right path. So this equation is level 1000. I don't know what I'm saying. All I know is if I'm trying to pick a variable, I'm looking at my x's. I have a 3 and a 5. Ain't nothing I can multiply 3 to make a 5, and nothing I can multiply 5 to make a 3, and then I got -2 and 5 for the y's, and it's just a mess. Like, what am I supposed to do here? So this is where you multiply both equations. At this point, it doesn't matter. One is not going to be easier than the other because both of the x's are positive, both of the y's are negative. So it's like, just pick one, and it's just going to be difficult either way, okay? So what I'm actually going to do is I'm going to multiply the pink equation by -3. Why -3? Because it's going to give me a -15. And then I'm going to multiply the top equation by +5. Why 5? Because it's going to give me a +15. So if I have a +15 and a -15, am I going to have my opposites? Yes. Yes, I am. Okay? So I'm going to have 15x minus 10y equals 10 for the purple equation, and the pink equation, -15x plus 15y equals -30. Do you see your opposites? Yes. We love it. So we're going to go ahead and get those out of here. And we're going to add down. So -10 plus 15 is going to give me 5y equals negative 20. And then I'm going to divide by 5. Y equals negative 4. So that's half my answer. So now what do I do with that y equals negative 4? Well, I go ahead and I plug it in. Does it matter which equation we plug it into? No, we could use the purple or the pink, but I'm just in a habit of using the purple, so here we go. So negative 4 goes in for the y value, not the x, okay? And I'm going to get 3x plus 8, because the negative times the negative is a positive. And I'm going to get x by itself. X equals negative 2. Boop. Those are my answers. So just because you found the y first doesn't mean the y goes first in the answer, because we all know ordered pairs are x, comma, y, like ABC order. X comes before y. I have to say these things all the time to my students. So how do you check your answer? Because we don't have the graph. So like, how do I know I did it right? I'm so glad you asked. Okay, so let's go, say you go into your calculator, right? You'll put the first equation in, and instead of x, you would use negative 2, and instead of y, you will use negative 4, okay? And you'll put it straight into, if it's a scientific calculator, it'll do PEMDAS for you, order of operations, and you'll press, when you press equal to, you should get the other side of the equation, so it says equal to 2. That means, good, it works for the first one, but we have to make sure it works for both equations, because we want to know where both lines touch, right? So 5 times, parentheses, negative 2, minus 5 times, parentheses, negative 4, okay? I'm going to press equal and see if it equals the 10 that's on the other side of the equation. And voila, it totally does equal that. We love it. Okay, so then we have example number 5 out of 6. So 2 more. So you know, if you're with me on the last 2 videos, you know the last 2 examples are usually what? The no solution and the infinitely many solutions. So we'll see what happens here. Okay, so I have these 2 equations, and what I know, what we got going on here? Oh, the bottom equation was not in standard form. Remember that it's best to do elimination when it's in standard form. So I'm gonna go ahead and swap the x and the 6. So it was a negative x, now it's positive, the negative 6, now it's positive on the other side. So we just got that in standard form. I'm looking at my variables now. Which one am I gonna choose, x's or y's? Honestly, you could choose either of those and it would be fine. I'm going to choose the x's. I'm going to multiply the bottom equation by negative 1. And then I'm going to get this. And once I get this, I have my opposites. But look, I have 2 pairs of opposites now. Whoosh. The x's and the 2 y's were opposites. So what am I left with? 0 cannot equal 14. That's not, I can't, what? What does that even mean? It means no solution, people. Okay, so that's how you recognize it while you're doing elimination. No solution. So you had 2 matching equations on the left, x minus 2y, but they equal different things. Negative 8 and then 6. Anytime that happens, you don't even have to do the work. You should know that it's no solution. We discussed this in the last video. Anyway, so let's look at this example. So I'm looking at my x's and my y's. Which one am I going to choose? Again, I could choose the x's or the y's. In this case, I'm going to choose the x's. And I'm going to multiply the top equation by what to make that a positive 6x? What number? This is what you got to think in your head. What number do I need to multiply that top equation by to get that 2 to be a positive 6? Oh, good. Look at you, you're so smart. Times 3. And if I do it to one thing in the equation, gotta do it to all the things because we gotta keep that thing balanced, okay? Look what's happening. I got opposites on both sides again. But 0 this time equals 0 because the negative 3 and the positive 3 are also 0. So when it's a true statement, it's infinitely many solutions. True statements, infinitely many solutions. Ta-da! In a nutshell, people. Okay? That is solving by elimination. What am I going to tell you to do? I'm going to tell you to do the same thing I always say at the end of my videos. Get a sheet of paper. Go back through the video. See if you can figure out the problems without watching me do it first. To see if you really get the information. And if not, I will see you in the next one. Later.